So let's tackle the first challenge first, the gap between the growing demand for resilient infrastructure and the shortage of engineers to do the work. We can't build our way through this. The focus of sustainable development must shift to adapting and optimizing the infrastructure that is already in place. More than 95% of the infrastructure that will be in use in 2030 already exists today. So the pressure is not just to deliver more infrastructure, but to ensure that the infrastructure that we already have is resilient, is efficient, and is capable of meeting the demands of tomorrow. Now, of course, the starting point is to have a better understanding of existing infrastructure. And as always, our users are showing the way. Here are 3 examples of projects that were submitted in this year's Going Digital Award. The Bridging Kentucky program set out to inspect and fix 1,000 deficient bridges. Now, based on past experience, this could take over 10 years and cost more than $700 million. To speed things up, the survey team led by QK4 used iTwin Capture and OpenFlows to create 3D models of over 700 bridges. With Bentley software, they finished the survey 90% faster and cut costs by 50%. That's 90 and 50. They created digital twins that design engineers can trust and use for construction plans, setting new standards in bridge surveying, design, and construction. Also, exactly. Also in Kentucky, the Ohio Falls Hydro Station includes 2 towers that were built in the 1920s, supporting a transmission line across the Ohio River. The utility company decided to reuse those towers instead of building a new crossing in another location. They hired EXO to inspect those towers, using iTwin Capture to process 250 gigabytes of drone photos into a reality mesh. And the resulting digital twin allowed EXO to assess corrosion and structural stability, identifying the best way to reinforce the towers. As a result, they avoided a potential 10 years of permitting delays and saved about $80 million compared to building a new tower crossing. And on the other side of the world, in Singapore, the Public Utilities Board has a smart water grid program to monitor over 6,000 kilometers of pipeline. While they use sensors, these only cover part of the network, so they still rely on labor-intensive field surveys. Now, to improve this, PUB combined OpenFlows with AI and ML, creating an integrated leak detection system that uses sensor data to update the hydraulic models on a daily basis. This new approach helped them find 2 major underground leaks between January and May of this year. These are powerful examples of how software has been used to gain a better understanding of the existing infrastructure. They're also a validation of our strategy to make asset analytics a priority going forward.